In this module, we will see how to operate the engines during the various phases of a flight and familiarize you with their functions and indications. It only requires a small increase of thrust to get the aircraft moving. After this, idle thrust is usually enough to keep it taxiing. On ground, thrust control is entirely conventional. The thrust lever position determines the amount of thrust. The thrust levers can be moved manually over the entire quadrant. They do not move on their own. They have 6 positions on the quadrant: idle, climb for maximum climb thrust, flex MCT, one detent serving 2 functions. Flex is used for reduced takeoff thrust. MCT for maximum continuous thrust is used for one engine out operations. Toga for maximum takeoff or go-around thrust. Idle reverse for idle thrust when reverse selected. Max reverse for maximum reverse thrust. Thrust control can be achieved in 2 ways: manually using the thrust levers as in any conventional aircraft, automatically when the auto thrust is active. Note, the FADEC prevents the thrust from exceeding the limit for the thrust lever position in both manual and automatic modes. Let's look at the indications for takeoff. On ground, the thrust limit mode is flex or toga. The selected mode is displayed in the upper right-hand corner of the engine warning display. Toga represents the maximum thrust available from the engine for the actual outside air temperature, OAT, of the day. The N1 rating limit displayed alongside the selected mode indicates the related N1 value. Flex is used for a reduced takeoff thrust. To achieve the thrust reduction, an assumed temperature or flex is used, for example 45 degrees Celsius. The flex temperature is displayed beside the N1 rating limit. This means that the engines will perform as if the takeoff was made at full power with the outside air temperature at the flex value. The result is that the actual takeoff thrust is reduced, which helps to prolong engine life. Flex takeoff will be discussed in more detail during the performance part of the course. Today, we will carry out a reduced thrust flex takeoff, as this is what you will do normally. The pilot flying progressively adjusts engine thrust in 2 steps. The first step is to move the levers from idle to approximately 50% N1. When 50% N1 is reached, flex takeoff thrust is applied on both engines by moving the thrust levers to the flex detent. Continue to apply the takeoff power. When you reach the flex detent, the pilot non-flying checks that the indicated N1 is the same as the N1 limit. The FADEX will maintain takeoff thrust and monitor for overspeed and temperature during takeoff. Note, toga thrust is always available by moving the thrust levers to the toga detent. At thrust reduction altitude, move the thrust levers to the climb detent when the flashing climb prompt appears on the Flight Mode Annunciator, FMA. Note, auto thrust will now be active. When the levers are in climb position, auto thrust is engaged automatically. The thrust limit mode turns to climb and the N1 rating limit changes. At 1500 feet above ground level, the ECAM engine page is replaced by the ECAM cruise page on the system display. Watch the N1 indicators. When the N1 value changes, an N1 command arc is displayed in blue, from the current N1 to the new N1 value. Note, it is only displayed with auto thrust engaged. When the new N1 value is reached, the command arc disappears. Let's see it one more time closer. The cruise page displays the fuel used for each engine, the oil quantity for each engine, and the vibration rate for N1 and N2. During cruise, descent and approach phases, auto thrust is normally active, and the thrust levers remain in the climb detent. In flight, if both engines are at idle, an idle indication appears. It flashes for 10 seconds and then remains at steady green. Note, there is a slight difference between flight and ground idle. If heavy rain or turbulence is expected after takeoff or during initial approach, it is recommended to select continuous ignition. Continuous ignition can be selected manually by moving the mode selector to the ignition start position. When selected, the message ignition is displayed on the engine warning display memo. Note, continuous ignition is selected automatically when engine anti-ice is in use. No switching action is required. During landing, the pilot moves the thrust levers to idle. During landing, there is a call-out to remind the pilot.
Retard, 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 retard.
After touchdown, reverse is selected immediately to help the deceleration of the aircraft. On the N1 indicators, REV appears in amber, indicating that the reversers are unstowed or unlocked. When the reversers are fully deployed, the REV indications change to green. As the aircraft speed approaches 70 knots, the levers should be moved to reverse idle. In order to extend the useful life of the engines, it is recommended to leave the engines running for 3 minutes after using maximum reverse thrust. To shut down the engines, the corresponding engine master switches must be set to off. Switch off engine 1. The engine shuts down. On the engine warning display, the fuel flow indication is 0, the EGT decreases, N1 and N2 decrease. Switch off engine 2. Engines 1 and 2 are shut down.